Today we're going to talk about, we talked about on Monday, DHCP for IP version 4. Today we're going to talk about how addresses are received by a client who wants to receive automatic addresses for DHCP version 6. We've already actually talked about this first part, and this first part we're going to talk about is SLAC, or Stateless Address Auto Configuration. By default, if you set up a Windows box to obtain an IPv6 address automatically, it is going to receive the address via the process known as SLAC. And so as we go down here and look with SLAC, there's a couple ways that we can do dynamic global unique address assignment. Actually, there's 3 ways we can do it. 2 of them are stateless, and 1 of them is a stateful, which is actually the best way to think about stateful is it's almost exactly the same way that DHCP works for version 4, but it's for version 6. But what I want to show you first is stateless, and in particular SLAC. So we're going to talk about stateless address auto configuration. To start with, what happens is when the client goes and initially boots up and it's set to get a dynamic IPv6 address, it's going to send a router solicitation message and say, I need a router advertisement from a router. The router will then send back a router advertisement with 1 of 3 different flags set. It could be the A flag, which means auto configuration only, which means SLAC only. It could send back a router advertisement with the O flag, which is the other flag, which means stateless auto configuration, or it could send back a M flag, which is managed, which says you're going to use stateful DHCP version 6. So when a client boots up, it sends out a router solicitation, and then it's dependent upon the router to tell it what version it is going to use. So remember again, one of the things that we need to remember is this, as we're looking, let me pull up here. Okay, so I'm gonna copy this. I'm gonna take it over into my WordPad here. I'm gonna drop it in. All right, so here we have this. So remember, if we get this, pull this over here, bring it over. All right. If the router advertisement has the A flag, it is SLAC only, stateless address auto configuration only. And I'm going to show you an example here in a second. If the router advertisement contains the O flag, the other flag, it does stateless address auto configuration, but what it will then also do is the router gives the host a IPv6 stateless DHCP server address so that it can go get things like domain name, your DNS information, those types of things. If it is the managed flag, so if the RA, the router advertisement, has the M flag, then it tells the host, hey, I can't give you any information about your global unique address. You need to go talk to the DHCP server. So those 3 methods map exactly to these 3 methods that we have for dynamic global unique address assignment. Now, what I want to do is give you an example of SLAC and how easy SLAC is. Remember, we talked about way back in Introduction to Networks. We talked about how your ISP is going to give you a /48 prefix to use with IPv6, which means you have an entire octet to use in order to do your subnetting. So what I'm going to do is I'm actually going to pull out the subnet 2001 DB8 ACAD :0:/64. So that is one of the networks. Now the next network in line would be 2001 DB8 ACAD :/64, and it will go on down 2, 3, 4, all the way down to 16,000 and change. Okay, But what we're going to do is we're going to take this and we're going to pull it out here, and we're going to use it, this one address right here, to set up Slack on R1. All right, so what's this? So we're going to go to R1. We're inside of here. I've already given it a name, R1. And we're going to look at our topology. So we're going to look at gig 001. We're going to set this up so that we can do Slack. So all we have to do this, by the way, is very simply this. First thing, you must turn on IPv6. What is the command to turn on IPv6? What's our command that turns it on globally?
Yeah, okay. IPv6 unicast router.
Yep, that is correct. So that turns it on globally. That's the first thing we have to do. Then we go to the interface, gig 001. All right. And we got to put an IPv6 address on it. So I'm going to do IPv6 add, and I'm going to put 2001 colon DB8 colon ACAD colon 0 colon 1 / 64. And then I'm going to also put a link local address on here because it's just good habit to do it. Colon 1 link local. Okay, now at this point, what's going to happen is in our topology, if PCA is set up to get a dynamic IP address via Slack for IPv6, it sends a router solicitation message over to R1. R1 looks at this network and says, you are on the 2001 DB8 ACAD 0 network. Assign yourself a random interface ID and join that network. So let's go here and look at this one. Now look what's already happened. So let's go to scale display. Let's go to actual size. Okay. And let's make it bigger so we can see it. All right. Let me make it full screen. I said I'm gonna make it full screen. All right. It's already asking me, do you want to become part of this network? The answer is yes. And so let's go in here and let's actually scale it. And let's go scroll down here, click yes. Now watch what's happened here. If I do IP config, look at what happened. This machine is on the 2001 DB8 ACAD 0 network, and it gave itself a random interface ID of this. You'll notice it is not EUI64 because there's no FFFE in the middle. And you'll see that there is the IP address that was obtained via Slack. So this machine went out with IPv6, sent a router solicitation message, and the router responded with a router advertisement that said, hey, we're using Slack only, and gave to the host, said, this is the network you're on, determine yourself a random interface ID, and now this machine could ping across because it has a global IP address. That's method number one. That is the default method for how we do dynamically global unique address assignment. Questions about Slack, stateless address auto configuration. You notice we got a problem. There is actually a problem with Slack, and that is if we go in here and do an IP config all, notice we have no DNS server really set. There's no global DNS server set here. We've got a broadcast, or which is actually ends up, this is not a broadcast, it's a multicast, but we have no global DNS server. We have no global DNS suffix. So in other words, if we use Slack only, we would have to go and on this particular machine, you would have to actually assign via the adapter settings, even though it's set to be DHCP for the IP address, you really should set this to be DNS. I had to put the DNS server by hand because Slack does not hand out DNS information. You'll notice all it sends out is the prefix information and the default gateway information. Prefix, prefix length, and default gateway. That's it. Questions about Slack? Real simple. Well, sometimes we need more than that. And that is where we come in. That was Slack. By the way, enabling it is very simple. You put an IP address on the interface and you turn on unicast routing and Slack is enabled. And the way you can tell Slack is enabled is if the interface is part of the FF02::2 multicast address, because that's the all nodes or all routers address. So Slack only, I just showed you that. The flag is A for auto configuration. And you'll see all you get is an IP address in the prefix and you get default gateway information. Okay. Now, if we move forward, now again, we've already talked about this. So I'm not going to spend a lot of time on it. The two methods, you remember the two methods to generate your interface ID. One is randomly generated, which is what almost everybody uses now, because EUI64 relied on taking your MAC address, splitting it in half, putting FFFE in the middle, and rotating the 7th bit. The problem with this, let's imagine you're in a country where they're trying to track you down. If you use this method right here, they can track your MAC address. So EUI64 has gone the way of the dodo bird. We don't use that anymore. One of the other neat things that's built into Slack is that before a host will bind an IPv6 address that it has made via Slack to its interface, it will do a duplicate address detection. It will send out a message and say, does anybody have this? Because it is possible, although highly unlikely, that with randomly generated 64-bit interfaces, two machines could actually set up and use the same randomly generated interface ID. It's very unlikely, but it's possible. So that's why it does a duplicate address detection. All right. So we also have another method, which is the other method. And if that is, it's called stateless DHCP operation. And when this happens, you send out a router solicitation message. You get back a router advertisement that has the other bit set. All right. So it says, here's your prefix. Here's your prefix length, here's your gateway, but also here's a DHCP server that can hand you some more information. And then you will then send a solicit, a DHCP v6 solicit over to the DHCP server, and it will return things like domain name, DNS server, all those options that we talked about with DHCP version 4. So the stateless DHCP really is kind of a between Slack and full stateful DHCP. You still receive your prefix and the prefix length and the default gateway information just like Slack, but you're also told to go talk to a DHCP server. You do this on the interface by putting the in the other. Now this is neighbor discover other flag. So this will allow, this causes the router when it sends the advertisement out to set that other bit, the other flag. And then also, obviously, you're going to have to create a DHCP pool with information to answer anybody that comes to it. We'll show you that in just a second. Okay. So that's stateless. Now stateful, or the final one, you set it to managed, ND managed, and if the managed bit is set to 1, what actually happens is when the PC sends out a router solicitation, the router sends back a message and says, I'm sorry, I can't give you your dynamic IPv6 information. You need to go talk to this DHCP server, or you need to go talk to a DHCP server, and then the PC will go and query a DHCP server for full stateful DHCP. So again, our three main methods: Slack, which is fully stateless; Slack with DHCP, which is still stateless because the DHCP server is just used to provide additional information; and then stateful, where all information for dynamic allocation is managed by the DHCP version 6 server. So let's look at how we set up a DHCP version 6 server. It's really very simple. You create IPv6 enable IPv6 routing, and that is with the IPv6 unicast routing command. Create a DHCP pool In this case, we're making a stateless pool. Configure information. Now you'll notice since this is a stateless pool, the only thing we're putting in here is the DNS server and domain name, because that's all it's going to give out. Bind the pool to an interface. You'll see here on this interface gig 001, we put IPv6 ND other flag and then our stateless. So what I want to do now is I'm actually going to go back into our example network. Okay, I'll go to R1 and we're going to try to make this work. Now I will tell you, I've had some issues with previous Windows 10 clients, but we're going to try to make this work. So what we're going to do, we've already enabled this. We're going to make us a pool. So let's back up one level. Let's do IPv6 DHCP pool, and we'll just call it stateless because I'm lazy and don't want to type out that whole thing. Just remember, it is case sensitive. So there's stateless. Now we're going to put in our DNS server information, and let's see, we'll steal their name. We'll steal what they used. So 2001 colon DB8 colon ACAD colon, I'm gonna put 0 colon colon 254. Domain name, we're actually going to change that one to KFC example example.com. It's my initials, by the way. All right. And then now what we need to do is bind that to the interface. But let's go first back to PCA. You'll notice, I'm going to cancel this. I want you to be absolutely sure that you can see this. And that is that we don't currently have on this machine, we have no DNS suffix and we have no real DNS server set. That's an automatic address that basically is a multicast address. So we're going to go in here and change that. So now what we're going to do is we're going to go to the inside interface, GI 001, which is you'll notice we look at our topology, that's this interface right here. And we're going to do IPv6, neighbor discover, other flag, and then IPv6, DHCP server, and it's going to be stateless. Remember, it has to match the name of my pool. Okay, I'm going to type exit. I'm going to do right. And now we're going to go back to PCA and we're going to do an IP config/release. I'm going to do an IP config/renew. Gotta spell it right. And give it a few seconds and hopefully we'll get a DNS suffix and we'll get a DNS server information. It'll take it a little bit. Probably actually should use I'm gonna speed this up. I'm impatient, so I'll make it happen like this. I'm actually gonna go in here and disable the interface. Then I'm gonna go in here and re-enable the interface. That makes it go back through the process of getting an IPv6 address. Now take a look. See what's happened? We now have the DNS name that I configured. And you'll also see it did not do the DNS server for some reason. Yeah, it did. Right there it is. Did it down here. Sorry, that's on a different Ethernet adapter. So right here you'll see that I now have the KFC example DNS suffix, and I also have the full DNS server that I put in there under R1. So you can see we're now working and using a stateless auto configuration with DHCP server. Questions about that? The key was, once again, creating a pool, giving it the information in that pool, and setting the flag to other. Any questions? So what do you think we ought to do to make it fully stateful? Any idea? The only thing
we have to choose the next option.
Yeah.
It won't be A. It'll be is it U?
It's
A?
M. It's M.
M.
Yep, it's M. So all we have to do, so let's go ahead and do that. So we still got to, let's create a new pool here. So let's go in and I'm going to actually go no IPv6 DHCP pool stateless. And I'm also going to go into the interface. Let me go back to my interface. And I'm going to no IPv6 DHCP server stateless. And I'm going to do, I got to change my flag. So let's go ahead and do this first. Let's pull up, pull this over here so we can see them both at the same time. So we're going to create a new pool. So let's X out of here. We're going to create a new pool, IPDHCP pool, and we're going to call it stateful. All right. Then we're going to go into that pool and we got to give it a prefix now, because remember, this is giving everything out. So our prefix is going to be 2001 colon DB8 colon ACAD colon 0 colon /64. Oops.
Didn't you have to put in when we did the DHCP pool that it was an IPv6 stateful?
Yep, I did wrong. I did wrong one. Yep. Good catch. Good catch. Sorry about that.
Okay.
That was my fault. Good catch. DHCP. Hey, that's nobody's perfect. And it's good to make mistakes like that. IPv6. I was testing it. That was my test. Yeah, sure. There it is. All right, now address prefix 201 colon ACAD colon actually 2001 DB8 colon ACAD. Golly, I can't type. Colon ACAD colon 0 colon 64 /64. And then I'm gonna do DNS -server 2001 colon DB8 colon 0. I'm gonna change it to 200 so we can see it change. Okay. Then I'll do domain name, and I'll call it stateful.
Doesn't that have to be in caps?
No, it does not. It does not, because that's just your that's just your DNS.
Oh, okay. It's just the name you're using.
Just the name. Right. Now, what does have to be in caps is this. When I go back to the interface, 001, I have to do IPv6 managed ND, and I got to do managed config flag, because now we're going full managed. And then I have to do IPv6 DHCP server, and this does have to match. So it has to be that. Okay. So now if I do a quick do show run pipe begin IPv6. Oh, okay.
And G at beginning.
Yeah. You'll see here we've got IPv6. There's our pool stateful. There's our prefix. There's our DNS server, and there's our domain name. So let's go back now and let's go to PCA. And again, I'm going to cheat. I'm going to actually shut the interface down. Then I'm going to bring the interface back up. And now we're going to go in here and do an IP config. You'll notice we're using the stateful pool now. And you can see that my DNS, my domain name server, my DNS server has changed from 254 to 200. So we are now using full stateful DHCP. So when this machine re-enabled the interface and sent out a router solicitation, it got back a message from the router that said, this is the managed flag, go talk to this stateful DHCP. And went over there, used that pool, and there we go. This is fully stateful. Everything's coming off the DHCP server. I should actually be able to go over here on this router and do a show IPv6 DHCP binding. And you can see here that here's my client. There's the client that's bound. And so it actually can show you the binding that has taken place here. So that should be 1C, 1C5F, 1C5F. So that's that machine right here. So you can see that this one DHCP server on R1 has handed out one binding to a client. So we've actually shown in examples today all three ways you can do dynamic, globally unique address assignment for IPv6. The two stateful methods, remember this is the A flag is set to A for neighbor discover for auto configuration. Other, the O flag, which is for stateless, so it gets some of its information from a DHCP server. And then the managed flag, when the M flag is turned on, it goes and gets all of its information for dynamic assignment from a DHCP server. Questions? Because that is really all there is to this particular chapter. The only other thing they mention is about a DHCP relay agent, which is works exactly the same as in IPv6 or IPv4. Imagine that the DHCP server is on R3 up here, and this client down here, PC1, needs to get to it. You would have to put a DHCP relay destination. The difference here is in the command. Remember, our command in IPv4 is IP helper address. In IPv6, you actually put IPv6 DHCP relay destination and put the next hop IP address and the outgoing interface it needs to go across.
Question.
Shoot, go ahead, Steve.
When we were configuring earlier and you went to identify the interface, you used GI 0/0/1.
Right.
What was the purpose of the I?
Gigabit interface. So
does
in other words,
does it matter? Because in this last example, it just said G 0/0.
no, G actually, see, GI, if I tab it, see, that's the full name. It's gigabit Ethernet. So I just use GI. So it can be G0/0/1. It will accept that. It'll accept GI. You can do either one.
Okay, I was just curious because I'm unfortunately I'm now learning how to look at the commas.
Yep, and that's a very important thing. But yeah, you can use either one, GI or G, or you can type the entire thing out. I mean, if you do that though, it's 0/0/1. You have to put a space between that. So watch this. Here's something. I went too far. Here's something that gets you in trouble. If you do int gig and then do 0/0/1, that did work. Sometimes that won't work. Sometimes it requires the space depending on the iOS version, but they must have just made that irrelevant. Most of us, 99% of the time, we're just going to do int G0.
Well, that's how I've normally seen you do it.
Yeah.
And then this time it said GI, and I'm like, okay, I must have missed what the I
just
meant.
First two letters in gigabit.
Okay.
That's it. The other thing that's same thing with the switch. On the switch here, if I wanted to int F06, I can use F06, or I can use int FA06. And sometimes I'll use them interchangeably. So sorry about that. But you
That's
know,
all
you
right.
can, you
I'm
can also
just
use,
curious.
yeah, you also use the entire command.
Okay, so it's kind of like Microsoft. There's 3 ways to do everything.
Yep, most definitely. Most definitely.
I got the expert.
Yeah. So other than that, that's DHCP and that's dynamic allocation of IPv6 addresses. I will tell you, one of the things you'll notice is that in this chapter, they actually do have you do a lab where you do all 3 of these. So it's something that can show up on the CCNA exam. So I would be aware of how to actually do what I just did, which is pretty simple when you run through it a couple times. Slack is easy. Slack, you just literally put an IPv6 address on the interface, turn on unicast routing, Slack works. It's when you get into the stateless DHCP and stateful DHCP, you have to do a little bit more work, but not much. It's literally 2 commands to set that on an interface. So these are very important for you to remember though, because again, this could show up on exams and could definitely show up on chapter tests, but the A flag is for Slack only. The O flag is for other, so it's for stateless DHCP. And the M flag is for managed or stateful DHCP. So I would definitely put those in a series of notes somewhere and kind of store them in your memory. All right. Any questions?
Prof, and when we are doing the internet, the first one, you talk about using 2 card for IPv4 and IPv6 that is going to roll over from the IPv4 to IPv6.
Right.
Does that one have any connection with what we are talking about now?
No, nothing in CCNA has you learning how to do IPv6 to IPv4 tunneling or anything of that nature. What we usually do is just what's called dual stack. And so in other words, we have both IPv4 and IPv6 on an interface. So in other words, given our example here, what I would do is I would do an IP address of 192.168.12.1. Y'all know that's my favorite IP address range. I do a no shut, and then I do Control Z. Now, if I do a show IP in brief, you'll see that I've got on here an IPv4 address, and if I do a show IPv6 in brief, I've also got an IPv6 address on it. So this is what we call dual stack. In other words, we're running both IPv4 and IPv6 on the device. And this is what we will typically and how we, in the world of CCNA, deal with running both IPv4 and IPv6. We don't try to do anything funny with conversions or tunneling or those types of things between them in this class, because that's a much higher level concept. That's a CCNP level concept. All right. All right. Some plans that I have, folks. I am going to go over first hop redundancy protocol. I'll wait to Monday to do that because it's a very, very short chapter, a very short item. And all you have to do is understand how it works with a little bit of looking at how easy it is to set up. We're going to talk about that in class on Monday. I am not going to lecture at all on this land security concepts, because this is really just a security plus module. Quite honestly, that's all it is. I will on Monday hit first hop redundancy protocol, and we'll talk about switch configuration. And then one of the things that you've got to do for me for these 2 chapters, 12 and 13, is you've got to watch all of these little videos that are in here. All the videos walk you through how to do the configuration of a wireless access point, and especially a wireless LAN controller. That is something we cannot do inside of NetLabs because I don't have Faraday cages. I don't have things I can run the wireless inside of NetLabs. So you're going to have to watch these videos, and we'll cover them as best we can by watching those videos. Good news is almost everything on the exam is just a concept. It's not a configuration item. And anything that is configuration, we do have packet tracers that will help you do that. So that's kind of our plan for coming up for next week. We are right now literally 1 month and 2 days from the end of this course and the beginning of your CCNA 3 course with Kirby Simerson. I hope everybody is working to get completed, and you know I am here if you need anything at all. Let me know, and I am here to help you in any way possible that I can. Any questions before I stop the recording, and then you can tell me anything you want to tell me.
I'm good.